a pretty sensible, reasonable person would be like, you're not hurting yourself. It's not expensive. You're not going like it. Just wear the mask, bozo. Like, shut up. Even if we don't know, it's kind of like accepting some religion as being yours because you're like, well, I'm going to die. I'll just put it as an insurance policy. So I'll just like say the things and show up and go through the motions. So with that, there's that person that could be just like, shut up, asshole, put the mask on. You're not sure, put it on, move on with your life. And then I wonder what the other kind of unforeseen ramifications of being in that position are. It's like, okay, what if we do transition into that type of culture where it is absurd to touch somebody or be within 6 feet of somebody, or, like how does that impact our health in a long-term way?
When is it going to be okay to not wear a mask?
Yeah.
If we all accept that it's okay to wear a mask, when is it going to be okay? I have no problem wearing a mask in a grocery store if it helps someone else feel more calm or less stressed. I don't think it's going to change the transmission of coronavirus one bit. And the factual reality is that 95% of the masks that people are wearing are way too porous to prevent the transmission of any sort of microscopic viral particle. So it's really, like you're saying, it's just, it does raise these issues. Like I said, I have no problem doing it out of the intention of protecting someone else. But like, let's talk about this reality, right? You have a surgical mask, that's one thing. But if you go to touch the surgical mask, then you touch food in the grocery store, you touch your face, it's different. But most of the masks out there are not surgical masks. They're mostly hand woven masks. I saw some celebrity on Instagram had a crocheted mask with holes in it that were big enough for a pea to fit through. And it was just like, if that's not virtue signaling, I don't know what is. And, a cloth mask made out of a bandana is doing zero. In fact, it's probably doing worse than zero, because if you, in fact, do have coronavirus and you are exhaling those particles onto a cloth bandana and you touch that cloth bandana to adjust it, you now have coronavirus on your hand. We're being told from the beginning, don't touch your face, which is great advice. If you have coronavirus in the oropharyngeal cavity, you probably shouldn't go picking your nose or sucking on your finger and then touching a bunch of stuff at the grocery store. So there's a real possibility that we've gotten so wrong about this that people with cloth masks, everyone touching their masks, are actually just putting the coronavirus on their hands, and then it's going on to fomites and other spaces. So the thing that for me is it's a little bit of a reaction against the groupthink. Like, shouldn't it be okay to question masks? That's the problem for me, is that no one is actually making it okay to question the status quo with some of these things because it's gotten so polarized. So
yeah,
that's my
it's
thought
just
about
such a tough situation because it's in, upon your questioning essentially from that side, it would be denoting that you're okay with murder. Like, that's the angle. Like, just through you going in and having some intellectual investigation and saying like, okay, like, let me weigh this out. It's like, no, it goes straight to the worst possible scenario. And then you kill my grandma. And so it's a weird place to have an opinion. It's a strange time in general to think what one would, deem freely. You're like, we've always been manipulated. Like, there's no way around that. You're manipulated by your culture and by your parents and, by your programming 0 to 7, and you're in your theta state and you're in this dream and you're just absorbing the world. And, who knows who we are. But in the modern world with social media and what is permissible and is not, it's like a whole new level of what I deem to be like, literally I feel like my thoughts are being tuned in a way. It's very fascinating.
Scary.
I wanted to talk to you about human evolution. That was the main thing that I was excited about in this conversation.
Yeah. Let's talk about it.
Yeah. I wonder, so from your perspective, could we get into a little bit of the impact that consuming animal foods has had on our minds, on our brains, on our evolution, like the origin of that? Most of this stuff is all completely theoretical. How confident do you feel about the theories?
Pretty confident. I mean, most of what we experience in life is difficult to prove in without doubt. But I mean, we're looking at something that happened millions of years ago. So of course it's all theory and hypothesis, but there's some pretty compelling theories here. So what is not theoretical is the fact that the human brain, the size of the brain within this cranium, within your cranium, within a skull, is the brain expands to fill the skull. So we can look at fossilized remains of our primate ancestors, chimpanzees, bonobos from 40 million years ago. We can look at Australopithecus afarensis from about 4 million years ago. We can then look at the next sort of hominid ancestors, Homo habilis, Homo erectus, Homo heidelbergensis. From 2 to 1.5 million years ago, we can look at Homo neanderthalensis from 100,000 years ago, and we can look at Homo sapiens who have been around for about 350 to 500,000 years. And we find fossilized remains of the skull 4 million years, as in the brain transitioned from less than 500 cc's around the time of Australopithecus afarensis to an apex of 1500 cc's. So the brain tripled in size in 4 million years, and the brain really tripled in size in the last 2 million years. Now, that may not sound so impressive when you think 2 million years, the brain got 3 times bigger, but this doesn't happen in other species. And what we know is that primates have the same size brain they have for 60 to 70 million years. Our primate ancestors, chimps, bonobos, really have had brains around 200 to 350 cc's for 60 to 70 million years of primate evolution with no change in their brain size. So something had to happen. Most people will acknowledge there is pretty darn good evidence that we evolved from primates, that we have primate ancestors. Something happened on the East African steppe about 4 million years ago. People think it's a tectonic shift, and that there was a change in the sort of forest ecosystem. It became more of a savanna. And our earliest ancestors, Australopithecus afarensis, were forced to come out of the trees and into the savanna, which changed their eating patterns. It changed what they had to do to survive, and that may have been the inciting event. But something else happened between 4 and 2 million years ago, because if you look at a graph of human brain size or pre-hominid leading to hominid brain size, it's very, very striking. Will you let me screen share, and I'll do this for people who are watching on Zoom?
Yeah, that'd be great. Yeah, that'd be awesome.
You might have to give me permission here. Let's see. Yeah, you have to just give me the permission. You go to the little caret screen, share screen.
Share screen. Okay, cool. Multiple participants can share simultaneously. I think I did it.
Okay.
Boom.
So check this out. This is a graphic from my book, The Carnivore Code.
Nice.
And I think it illustrates it pretty well. So the Carnivore Code, the second edition, comes out on August the 4th. You can see the primate ancestors going back millions of years, something like chimps or bonobos, Australopithecus. This is Africanus, but there's another one, Afarensis. Homo habilis, Homo erectus, Homo sapiens neanderthalensis, Homo sapiens sapiens. Now, look what happens here, right? This is what we might call a parabolic curve. Something major happened here in human brain size right here. So you could make all sorts of hypotheses. What happened 2 million years ago? But what's really interesting is you see this co-occurrence of many things that suggest this was hunting. And as I indicate here on the graph, this is the time when we see the first fossilized hunting implements. And we see also cut marks on bones. We see mass graves of animals. And we start to see evidence of butchering, and then we see both stone tools and, like I said, hunting implements. Then we see the human brain continue to grow, Homo erectus. The oldest evidence we have for fire is 1 million years ago, and most of the evidence suggests that fire is about 500,000 years old. So there is an anthropologist, Richard Wrangham at Harvard, who wrote a book, Catching Fire, and I think in that book he at least partially hypothesized that it was fire that allowed our brains to grow. But if you look at the temporal relationship here, it doesn't quite correlate. So it's possible that in the future we will find evidence for fire at 2 million years or much later, which may suggest that these things happened in tandem and that hunting and fire were together, triggers for human brain size growth. But right now, fire wasn't around for a solid million years. And then you can see the oldest evidence we have is about 1 million years, continues to get bigger. Right about 30,000 years ago, we hit an apex of about 1,500 cc's, and since then we've been shrinking in our brains. And as you know, shrinkage is never a good thing. So we can talk about why that might be, and I talk about why that might be in the book. But this is a really fascinating thing, and you see this kind of coherence of evidence suggesting, hey, we were hunting. Now, there's something else really cool that I can get a picture of here in screen share, which are called Acheulean tools. And these are bifacial tools. I don't know if you've ever hunted for arrowheads when you were a kid.
Absolutely.
Yeah, they were the coolest
That
thing
was
when I
so
was a
fun.
kid. I loved it, man. I grew up in Virginia. I went to the Smithsonian Museum of Natural History, and they actually had arrowheads. And if I ever found an arrowhead, I felt like I was king of the world. So Acheulean tools are bifacial tools like these that are about the size of your palm or a little bigger, that are clearly shaped by humans and meant to be either hunting implements, or this is essentially the first turbo ginsu. This is the first hunting knife. This is what was used to butcher meat or to carve meat off of bone. And they're
Wow.
these bifacial tools. How old are these? 2 million years old. So that's the first time we see this is 2 million years.
Hmm.
We also then begin to see evidence for cut marks on bones in fossilized remains of animals at the same time. So I'll try and find a picture of that. And it really begins to suggest, hey, we were hunting animals and we were butchering them just about the same time that our brains begin to grow.
Hmm.
So this is really kind of cool. I think there's some good ones here I can show you. These are a little bit, let me screen share this one. There's a lot here. You can see over here, these cut marks on bones that are also about 2 million years old. These are kind of similar. This is one of the more striking ones down here, but I'll enlarge this one. You can see cut marks here. You can see evidence for our ancestors breaking bones to get to the marrow. These kind of cut marks on bones at the insertion of the bone, kind of where the tendon would insert. So it's pretty interesting to look at these and think about the timing of these things and when our ancestors were cutting these bones. So then we also have these mass graves of animals saying, oh, our ancestors got smart enough to herd animals into blind canyons and slaughter them in mass. Now, what's fascinating about this is it all kind of comes together when you think about the nutrients you need to grow a human brain. So I'm good friends with Tommy Wood, who's a neonatologist, or he works in neonatal research, and he looks at sort of brain injured kids and brain injured babies at the University of Washington. And if you listen to his conversations and in all the talks I've had with him, there are a number of nutrients that it takes to grow a big brain. And they are the nutrients that are found specifically in animal foods. They are nutrients that do not occur in plant foods. Things like creatine for ATP and energy, things like docosahexaenoic acid, which is DHA, things like niacin, which is a B vitamin that is really not that present or prevalent in many plant foods, and it's much less bioavailable in plant foods. And then things like B12, which we're all familiar with. There have been some pretty striking population surveys, which are admittedly observational, but the correlations they note are pretty striking, and they generate some compelling hypotheses. And the hypotheses, the correlations they see are that in populations in, I believe it's Britain, it was a study done in Oxford, and I talk about this one in the book, it's in the references of the book, that the level of B12 in the blood correlated with the brain size in elderly people that they were examining. So those who had the smallest brains also had the lowest amount of B12 in their blood. And you can measure B12, or you can measure methylmalonic acid, or you can measure holotranscobalamin as measures of actual B12 status. So where do we get B12? Exclusively from animal foods. There are some who would claim we can get it from dirt or from water, but if you really look into the scientific evidence for that, it's lacking. There's the only evidence of humans getting any amount of vitamin B12 from dirt is when humans farm plants in what's called night soil, which is soil made with human manure.
Well, even with that, you're getting the reason you're getting the B12, like in the rain droplets example, or the dirt, is because it's coming off of animals. It's coming off of what is it, bacteria. And well, with the raindrops, isn't it? It's like going through the atmosphere, and there's like bacteria or something, little critters that it's passing through. I don't actually know. Do you know bacteria, what the story with that is?
Well, most of what I've seen, actual B12 existing in the soil is a B12 analog that isn't bioavailable for humans. So much of you can't really get enough B12 from normal dirt. You can get B12 if you eat your own poop. So, because there are some bacteria in our guts that may make it or recycle it. And then the story about water was looking at these English ponds. James Wilkes claimed that you could get enough B12 from English ponds, and you might be able to get to the lower limit of the recommended daily allowance of B12 for a short time of a year in this one pond in England, which is so full of protozoa called euglena. So if you drank 3+ liters of water from a pond in England, and you got enough of this euglena, which is a protozoa, and the water certainly wouldn't be healthy looking or very palatable, you might get close to the lower limit of RDA for B12. But that's only one time of the year. At other times of the year, if you look at the article, you would have to drink upwards of 20 liters of that water from one pond in Europe, not a free-flowing stream out here in Austin or somewhere. I can't just go drink water in Austin and get enough B12. If this one pond in England, they found if you drank 20 liters another time of the year when there wasn't as much euglena, that's how much you would have to drink to get enough, like just close to the bottom end of the RDA, which is not enough for most humans for B12, and certainly not enough to give humans adequate reproductive capabilities or make them thrive. So claims that we can get B12 from the environment are essentially baseless. We need to get it from animals.
The thought with the rainwater, I'm reading just the thing is that it's, rainwater as it's falling through, it's not just pure water. It's going through the atmosphere, and it's potentially going down like rooftops and such. And then in that process, it potentially gathers little microorganisms that would contain vitamin B12.
Maybe.
But that's probably really little bits. I'm not suggesting that we stop eating fish and just start eating water off of the roof. I'm just saying that's the thing. But it's still coming from little critters, little microorganisms that you're
all those roofs 2 million years ago, all those tin roofs,
right, whatever.
But the idea here is, you see the point I'm making, that there are unique nutrients, and this is one of the things that I mentioned in the carnivore code. There are unique nutrients found only in animal foods. Many times people will look at plant foods and say, oh, there are phytonutrients in plant foods. And this is something that I sort of don't think is very factually correct, and we can get into that if you want. I talk about it in the book. But if you try and flip that equation on its head, what you realize is that the reverse is really not true. There are no nutrients found in animal foods there are no nutrients found in plant foods that we can't get from animal foods. That's just scientific nutritional fact. But there are many nutrients found in animal foods that we can't get from from plant foods. And so creatine, carnitine, choline, carnosine, vitamin B12, vitamin K2, the full spectrum of menaquinones. Though some would claim we can get vitamin K2 from natto, that's usually only MK7 and maybe MK9. We can't get, I've never seen any evidence we can get a full spectrum of the menaquinones from vitamin K2 from any plant food. And the reason there's vitamin K2 in natto is because of bacterial fermentation, not because of the soybeans in it in the first place. But the list of nutrients found in animal foods is long. And many of these nutrients are found in the muscle meat, but the majority of them are found in organs, which is another thing that I'm super fascinated by and really speaks to the importance of getting organ foods in the diet. For humans to grow big brains, there is a very large amount of evidence that we needed large amounts of both calories and specific nutrients like the ones that I'm talking about to allow our brains to grow. We see this in developing brains now of little baby humans, and we see it probably in our ancestors. Moving out of the trees, Australopithecus, Homo habilis, Homo erectus, and then suddenly being able to hunt animals gives us access to both more calories in the form of fattier meats and gives us access to larger amounts of nutrients that we never had in the past. And so there's a lot of evidence, there's a lot of theory and a lot of evidence to support the hypothesis that that was the inciting event. And the suggestion that I make in the book is that eating animals made us human, but not just eating meat, eating animals nose to tail, eating all the organ meats. Because if you see currently living hunter-gatherers and indigenous people, they always eat the whole animal. They eat the liver and the spleen and the pancreas and the kidney, things that seem gross and unusual to us, but are full of unique sets of nutrients that are not found in the muscle meat. So I think there's a lot of evidence that this was the spark that made us human.
Do you know the origin of the split away from organ meats, where all of a sudden it became like the classier thing was to eat animal muscles as opposed to organs? Do you know why that happened?
I think we just became weak and lazy. I don't know, to tell you the truth. I don't know.
Because it was a cultural decision. If you historically / animals in nature, it seems to be like that's the direction they go, is for the fatty stuff.
They go for the liver first,
the organist stuff and all that. So there was some we're so guided by cultural taboos, and we're within the confines of what the structure of culture. And so at some point there was a decision that brains are gross, eyeballs are gross, this stuff's gross, chickens are okay, dogs not okay. Like it's very interesting how we've marched along, kind of deemed what is and isn't not correct, even if it goes against what's correct biologically speaking.
Or evolutionarily consistent, what our genes are expecting. I think in 2020, we live in ways that are very evolutionarily inconsistent. And, maybe we'll survive for another, 70 generations and we'll adapt. And, what we're doing today will be evolutionarily consistent. But what we're doing now is something we've only been doing for a short amount of time. It's really been a blink of an eye evolutionarily that we haven't been eating organs, and that we've been using more vegetable oil, and that we've been using such high doses of linoleic acid, which we can talk about too, this omega-6 fatty acid found in vegetable oil. So big problem here. I think there's a lot of evolutionary inconsistencies.
What is the impact that some of those oils have on us, specifically at a cellular level, with like metabolically? Like, what's the issue with
Oh
subpar
yeah.
oils?
Oh, it's super interesting. I'll talk about that. I just want to share one more article, which I think is really cool.
Yeah.
Big brains meet tuberculosis and the nicotinamide switch. So nicotinamide is essentially an isoform of niacin. And the idea from this group of anthropologists at Oxford is exactly what I'm talking about, that because of NAD and NADH, which are key intermediates throughout all of human biochemistry, we needed large doses of niacin. And if you look at it, the only place you're going to get that is from animal meat. So it just goes back to the idea that animal nutrients are involved in making brains big. And the more of them we eat, probably the better we will do. So linoleic acid is quite an interesting rabbit hole to go down. This may get a little bit twisty and turny. So if you look at indigenous hunter-gatherers currently living on the planet, and you look at where they get their food, and you look at the amount of linoleic acid, which is an 18-carbon omega-6 fatty acid in the foods they are eating, it is very low. Most animals in nature do not accumulate large amounts of linoleic acid in their fat. And if you do the math, whether you're talking about the Tucasinta or the Tokelau Islanders or people in the Polynesian atolls, or you're talking about the Hadza, the Ikang, the San, or the Kawi-Meno Bushmen, or the Kawi-Meno from Amazon, the amount of linoleic acid in their diet by calorie is 2 to 3%. If you look at what's happening in human evolution, or I should say in terms of westernized human evolution, since 1865 and then more recently since 1911, the amount of linoleic acid, this 18-carbon omega-6 polyunsaturated fatty acid, has been going up and up and up because we've been eating more processed food. Specifically, we've been eating processed food that contains processed vegetable seed oils. Corn, canola, safflower, peanut, soybean, sunflower oils are much higher in linoleic acid than the animal foods that our ancestors have primarily consumed. So our diets have now become 17+% linoleic acid by calories. People might say, what's the big deal? But when you really look at the biochemistry, these polyunsaturated fatty acids, specifically linoleic acid, serve signaling roles in the human body. They act as what are called lipokines. And some fats that we eat, when we eat them, they do not affect the level of that fat in our blood. Other fats, when we eat them, they do affect the level of that fat in our blood. So when humans consume polyunsaturated vegetable oil, when they consume polyunsaturated fats from vegetable oil, the amount of polyunsaturated fat in our blood goes up. Our body doesn't have a good way to control this, and our body doesn't have a good way to get rid of this. We end up storing polyunsaturated fat in our adipocytes, in the fat cells. So you can tell how much vegetable oil or how much linoleic acid someone has been eating by looking at the cell membranes of their red blood cells or of their fat. You can do a fat biopsy. I've done this with my clients, and I can tell, like, hey, why are you eating so much linoleic acid? And they say, oh, I've been eating a lot of pork. We can talk about why pork is high in linoleic acid, because it's fed corn and soy, and monogastric animals like chicken and pork can't control the amount of polyunsaturated fat in their own adipocytes, in their fat, just like humans. So chicken and pork, like humans, when we eat grains, when we eat corn and soy rich in linoleic acid, or we eat vegetable rich in linoleic acid, or we eat animals who have been eating corn and soy, like chicken or pork, our fat will become higher in polyunsaturated fatty acids like linoleic acid. The problem is that that is an evolutionary signal. Linoleic acid, that one molecule, fats act as hormones, as signaling molecules in the human body. They're called lipokines. And linoleic acid plays this very critical evolutionary role to signal to humans, I believe, that winter is coming. So you should get fat and insulin resistant to store as much fat as you can, because you are going to soon be in the middle of winter and you will die if you do not have excess fat stores. The problem for most of us, oh, your mic is still off.
Why would that be an indication that winter is coming?
Because when you actually look at what linoleic acid does, so linoleic acid foods evolutionarily are foods that we would probably have hunted or gathered, well, generally have gathered near the winter. So the only place we would have gotten linoleic acid in nature is from lots and lots of seeds.
Okay.
So the only place that linoleic acid really occurs in nature is seeds. So the idea is that perhaps, I don't think a lot of humans have this, but within, latitudes further from the equator, if near the winter in the fall, we were gathering more seeds, that would signal to the body, hey, you should become fat now because winter is coming.
But couldn't you argue with like that perspective, that by eating a lot of animals, that perhaps winter is here if you're only eating animal products, because other plants wouldn't grow at that point?
Well, but animals don't have, you're absolutely right, but animals don't appear to have any of this linoleic acid. They have very low amounts of linoleic acid. So ruminants, like cows or buffalo or bison or aurochs, which is the ancestral relative of a cow, or deer or antelope, ruminant animals don't accumulate linoleic acid. So basically what I'm saying is I'm just trying to tie these disparate threads together and think, why would linoleic acid do this? It does occur in animals, but to much lower amounts than we are eating it today. Yeah. And the best theory that I can come up with, a hypothesis that, in the fall, perhaps we were exposed to a little bit more of this and it allowed us to become a little bit more fat to protect us from the winter. But now we are exposed to linoleic acid every day of the year in massive amounts. And what happens at the level of our fat cells, so there are two fat depots in the human body. There is subcutaneous fat, which is below the skin. And there's another depot of fat called visceral adipose tissue, which is inside the peritoneum, inside the abdominal cavity, basically around the abdominal organs. And that fat around the abdominal organs is very metabolically and endocrine. It's active. It's an endocrine organ. It's like a gland, like a pancreas or a testicle or an ovary. It secretes hormones. In this case, it secretes lipokine hormones that signal to the rest of the body whether the rest of the body should be insulin sensitive or insulin resistant. And so what appears to happen, and this is again a deep rabbit hole that we can go down in more detail another time, is that when we eat polyunsaturated fat, when we eat linoleic acid, the adipocytes, specifically the adipocytes within the visceral adipose tissue, grow and grow and grow. And eventually they get too big, they get distended, and they start to signal to the rest of the body, hey, you should become insulin resistant. And so what we have now is this totally evolutionarily inconsistent linoleic acid signaling, because we're just bathing ourselves in linoleic acid all year round. We're eating vegetable oil all the time. And I think that for most people, the cause of insulin resistance, the cause of metabolic dysfunction is not carbohydrates. Carbohydrates do not cause diabetes. Carbohydrates do not cause metabolic dysfunction. There are many indigenous groups who eat lots of carbohydrates and don't have any problems with metabolic dysfunction or insulin resistance or diabetes. These are all synonymous. But without fail, if we introduce vegetable oil into these populations, and we see this with transitions from indigenous hunter-gatherer lifestyles to more westernized lifestyles, like Weston A. Price observed in the 1930s, we see them get diabetes rapidly, very, very quickly. And it's that one ingredient, that change in that one lipokine, that one signal, that one molecule, linoleic acid, which has an evolutionary role, but it's being misused because humans are not supposed to get this much linoleic acid in our diet. At a mitochondrial level, if we really drill down, you can understand why this is happening. But it has to do with the electron transport chain and the ratio of FADH to NADH2 that happens when a polyunsaturated fatty acid versus a saturated fatty acid is broken down via beta oxidation, and then the reducing intermediates generated from that go through the electron transport chain in certain ways, and they can generate more reactive oxygen species with certain types of fat versus other types of fat. But that's probably way too granular for the last.
Do you got to be out of here at in 15 minutes?
Yeah.
Yeah. Okay. Is there some explanation that would be more elementary, just because we don't have very much time, of how the body determines its production of visceral fat versus whatever, appendicular fat, not in around your visceral territory? Like, how do we avoid belly fat?
It's really like I was saying, it sounds crazy, but you just don't want to have excess linoleic acid in your diet. I think if people...
Do you think that's the root of visceral fat?
Absolutely, brother.
Really?
Yeah.
That's elementary AF. Thanks.
Yeah,
Stop
you
eating
want
shitty oil. Done. That's
done.
it.
Watch what happens. Watch what happens. So I give people three steps, right? If you want to kick a lot of ass, you got 3 steps. First step, and again, this is just my hypothesis. Obviously, I'm sort of carnivore biased, but the 3 steps are: number 1, vigorously, religiously, vehemently eliminate all vegetable oils from your diet and limit your intake of linoleic acid in all of its forms. That is, animals that are fed corn and soy, which are chicken and pork, and anything else that might have higher amounts of linoleic acid. You actually want to go through and do a calculation. I should probably just write a book about this. Do a calculation, understand how many calories a day you're getting from linoleic acid, and make sure it's less than about 3%. And then just doing that, I think we would absolutely reduce the chronic disease epidemic. That's just step 1.
Which oils do we do? And for what purposes? What do we cook with? What do we put on put on salads? Oh, no, not salad. Sorry. What do we put on meat?
So just so your listeners know, I don't eat a lot of salads, but we can talk about it. Okay. So we talked about polyunsaturated fatty acids. These are long chain fats that have multiple double bonds between the carbons. And then there are also monounsaturated fats like olive oil. And the story is not quite as clear with monounsaturated fats. If you are using fat, I think that the most evolutionary historical advice suggests animal fats are way better than plant fats. This means tallow or ghee or butter above everything else. 100 years ago, you could use lard when pigs were not fed corn and soy. But with pigs being fed so much corn and soy, lard has too much linoleic acid, in my opinion. So ghee or butter, if you're not sensitive to casein and whey, or tallow is my favorite, which is rendered fat from the suet of animals, which is the kidney fat. The suet of animals is very high in a fat that appears to be quite healthy for humans called stearic acid, an 18-carbon saturated fat. So stearic acid also has a hormonal role, and it appears to be the total opposite of linoleic acid. So if I could contrast 2 things, I would contrast: you want more stearic acid in your diet from animal fat, and you want less linoleic acid in your diet from vegetable oils. And so that's what you really want to do. So you want to cut out, like I said, corn, canola, soy, peanut, safflower, sunflower, all those religiously, get them out. And really, you want to be careful about consumption of too many animals that are eating corn and soy, because what do we know about chickens and pork? If they're eating corn and soy, the amount of linoleic acid in their fat basically triples or quadruples, and they become enriched in linoleic acid too. But that's your take home. That's just step 1. Step 2 for me is don't fear red meat. These are the things I talk about a lot in the carnivore code. I think red meat has been incorrectly vilified for years and years based on faulty epidemiology, and is a central part, like we talk about with the human brain, of being healthy humans. Don't fear red meat and get organs into your diet. If you can't eat the real organ, do something like a desiccated organ supplement. We can talk about Heart and Soil, which I just launched, which is a great, exciting thing that I'm doing to get people desiccated organ supplements. And then the third piece is understanding plants on a spectrum of plant toxicity and understanding which are more toxic and which are less toxic. And again, this is all the stuff I talk about in my book, The Carnivore Code. But the first step is the most important. Those are in order of importance.
What would be the bottom 3 or 4 vegetables that people or plants that people are all about, that you'd be like, no, and then like the top 3 rung of like, I think these are kind of on the edge of being okay, even from a carnivore perspective?
Right. Oh, I just want to make sure I answer your other question fully. So to get an oil that is liquid at room temperature is tough. Right. To get an oil that's liquid at room temperature is tough because some might say olive oil is better or avocado oil is better. But when you really look at it, like I just saw a statistic that 80+% of avocado oil is cut with vegetable oil now. So you better be very careful about what kind of avocado oil you're getting. And I think that at a biochemical level, I'm not convinced that monounsaturated fat like oleic acid is totally benign either. It's probably way better than, or at least significantly better than vegetable oil, but I can't be sure that monounsaturated fat like olive oil is totally benign or won't cause your visceral adipose tissue to grow either. There are studies in animals. Again, these are animal models rather than human models. There are studies in animal models that show that oleic acid, specifically high oleic acid safflower oil, also causes visceral adipose tissue to grow, where stearic acid, the 18-carbon saturated fat found in suet and animal fat, causes it to shrink. So I think that in terms of liquid oil on salads, maybe maybe olive oil, but I can't say for sure that I'm convinced it's totally benign for humans. Salads are a recent invention. There was no salad dressing 200 years ago, right? So let's just keep that in context. And then
Because we got to wrap up. I wanted to talk about the brain shriveling up, getting smaller.
Yeah.
When did that start happening, and what's the hypotheses as to why that's taking place?
Yeah, and then I'll answer your. Let me talk about the vegetables, and then I'll talk about that. So, worst vegetables for people in the carnivore code. I give my perspective on a plant toxicity spectrum, and I think that one of the problems, and we may respectfully disagree with this about this, is that leafy greens. So, I think the worst stuff people can eat are seeds. So, nuts, seeds, grains, and legumes, I think, are the worst parts of plants because they're so highly defended. They are the plant babies going down the River Nile with. They look totally vulnerable, but they're highly defended with digestive enzyme inhibitors, all sorts of problematic compounds in those plant seeds. The next one is the leafy greens. I think spinach and kale and broccoli cause so many problems that we don't know about. So if people, those are the foods people think are healthy, and I think that they are the furthest thing from being healthy. Plants are rooted in the ground, and they have just filled those parts of the plant with defense chemicals. And I really think the majority of humans are not good at detoxifying them. There's a whole argument about hormesis, which I go into in the book. We probably don't have time to differentiate molecular from environmental hormesis today, but I think that the hormesis arguments really fall apart when you examine them critically. So those are the worst plant foods, and I think the best plant foods are fruit, the part of the plant that the plant actually wants us to eat. It doesn't want you to eat the seeds, but it wants you to eat this fruit, which is going to spread the seeds. So I think people will probably be more able to tolerate things like avocado or berries or apples or mangoes. Some people have sensitivity to mangoes because of the urushiol in the skin, but those type of things I think will be better for humans in general and are more evolutionarily consistent. So, and then shriveling brains, significant shrinkage, never a good thing. If you look at the fossil record, it's happened with the advent of agriculture. So this is something that Jared Diamond has talked about and called the worst mistake in human history. And I think it's quite interesting. Chris Ryan talked about it a little bit in Civilized to Death and some of his other books. But what we see with the cranium size, looking at the fossilized remains, is that in the last 20 to 30,000 years, as cultures across the globe began to adopt agriculture, our brains got smaller. And I think that the story, we've already told it here. If you stop eating animals and you start relying more on grain-based carbohydrates, which are very micronutrient poor, you may be able to get enough carbohydrate, you may be able to get enough calories, but in terms of micronutrients, you will be severely limited. Those B vitamins are really not that present or bioavailable in grain-based carbohydrates, nor are many of the other nutrients we talked about even available. There's no creatine, there's no carnitine, there's no choline, there's no carnosine, there's no K2, there's no B12, there's no riboflavin in any of those foods, or there's a very small amount that's not bioavailable at all. So it's a pretty bad predicament for most people, and it's the cult of the seed. It's the transition to an agrarian lifestyle, which correlates with a real decline in our nutritional adequacy. And we see that in terms of fossilized remains. We see increased lesions in the skull, which are spongiform. They're called parodic hyperostosis. They correlate with nutrient deficiencies and anemias. We see more tuberculosis lesions. We see shorter femurs, the bone in our upper leg, shorter humerus lengths. People were getting shorter, they were shrinking. And we see more evidence of pathologic fractures and actually bone infections after the advent of agriculture in any population. So that's a transition I talk about in the book as well. So it's pretty clear, eat animals, hunt a lot, humans thrive. That's probably a species appropriate diet. Stop eating a lot of animals, turn more toward grain-based carbohydrates and an agrarian lifestyle. Humans don't do so good. So I'll just mention my goal with the carnivore code, and the message here is not to convince everyone on the planet to stop eating all plants. It's just to help them understand that red meat and organs especially are incredibly valuable for humans and have been incorrectly vilified for the last 70 years, and that plants do exist on the toxicity spectrum, and some people may have more sensitivities to them than others and could have continuation or persistence of immunologic issues or other sort of suffering if they're not understanding that many of the foods they're eating, many of the plants they're eating may be harming them. So
I would think, as you're saying that, the beginning of the agrarian age, that being kind of the decline of cognitive function / brain size, I would think a major part of that that would be running right alongside would be once the food stops running away, then you stop running towards it. So there's a huge movement conversation there as well. So now my role is to kind of set it and forget it. And then I go in my lazy boy and just allow my brain to essentially shrink up. So synaptic potentiation and neurogenesis and cognitive function and memory, like all those things, like you need to move the wheels. You're like one of those wind up flashlights. In order to get light, you got to wind it up. And so 10,000 years ago, we kind of stopped winding it up, I think.
We pretty much did. I mean, you can also imagine the positions that people are going to be in when they're harvesting crops. They're not always going to be in a super good squat. They're going to be bent over or just sitting there. And you're not tracking food. You're not solving the same complex sorts of problems. Absolutely. It seems to be a real catastrophe. And we didn't even really get into the ethics of eating meat. It's something I talk about in the book. Regenerative agriculture, the importance of creating ecosystems within any particular environment, and how monocropping, which really grew out of any agrarian society, depletes the soil of nutrients and causes basically civilizations to fall apart time after time. I mean, we all assume in 2020 that this Homo sapiens civilization we've been living in is going to be around, but it's probably not. And even more similarly, we assume that this modern quote unquote civilization that we're living in is going to be around. But how many civilizations like ours have vanished from the face of the earth? Aztecs, Mayans, etc. And there are many arguments as to why that happened, but I think one of the most compelling ones is that most of them started farming, and if you over farm the ground, you will die.
You can even see, we'll be done in 30 seconds. You even see in anatomical charts, if you look at anatomical charts like spinal charts from, I think like the early 1900s, like 1912, I think I was looking at one, compared to today, the spines are much more upright and elongated. You call it like a J spine. Friend Esther Gokale refers to it as that. Kind of the butt comes out. You see like African tribesmen with the water on their head and all that stuff. You see that elongation of the spine. It's just literally, it's like a different body that moves in those ways. And then modern day bodies, it's just, Homo sapien is turning into Homo fragilis, is a term that I got from somebody else, but it's literally like, it's a continuation of the evolution, but it's going in a direction of collapse, one could say. And what is collapse? Collapse is a word. What does that actually mean in a long-term grand 30,000 foot view of things? Who knows? You have another interview to go to. We should continue this again.
I love it, dude. Thanks for having me on. But I have to agree with you completely. We are becoming fragile biochemically. Yep. We are becoming fragile physically, and those are connected clearly. But we're becoming fragile metabolically. We're becoming fragile, biomechanically. I couldn't agree more. So totally agree.
Where should people go from here? Get the book, Carnivore Code. What else?
Yeah, I hope you guys will check out the Carnivore Code. It releases August the 4th, thecarnivorecodebook.com. If you think I'm crazy and I'm full of shit, then you should read it and write to me and tell me how I don't know what I'm talking about. But there's over 650 references in there, and I think it'll hopefully open some minds. If you're interested in organ meats and you want to get more organs in your diet, I hope you'll check out Heart and Soil. It's this sort of passion project company that I've just launched, heartandsoilsupplements.com. We're making these desiccated organ capsules out of liver, bone marrow, heart, kidney, liver, pancreas, spleen. We've got all kinds of good stuff coming. And you can follow us on Instagram at Heart and Soil Supplements, but they're sourced from the best farms we can find in New Zealand, grass-fed, grass-finished regenerative farms. We put them into a capsule, so it's super convenient for you.
That's awesome. I greatly appreciate you, Paul, as you already know. I appreciate you more over getting to know you, just because you go against the grain of a lot of different perspectives, and you're like, well, this is how I feel. I'm going to keep on feeling into it and keep on researching and building this perspective. But I think you're also malleable in that. I feel like I've seen your language and kind of approach and perspective on things kind of shift over the last year. Not to say that you're like conceding and saying plants are good for anything like that, but I've seen you open up a little bit. And I also see you standing strong towards what you feel is right. And so I appreciate that.
Man, I appreciate you so much, brother. I think we all have to admit we're never going to be right about everything, and it's all about just learning. I actually hope that I'm wrong about some of this so that we can collectively understand what's right and people can ultimately just live better quality lives. But I think we have to be able to be free to challenge the status quo, and that's something that's super fun to do.
Got to. We're not educated how to do that. Thanks for teaching us, Paul. Lead by
I'm just
example.
part of the tribe, brother. I'm not
Yeah.
teaching you.
All right. Well, cool. Well, thanks so much. We will, like I said, I'm planning a tentative move to your territory, part of the world, in the next, like, very soon. So
couldn't be happier about it.
yeah, I love it. All right, cool, brother. I will. I'll talk to you soon.
Later, man.
All right. Thank y'all for tuning in. How do I stop recording this thing? Press